Pepper plants are popular at the Museo de Ciencias Naturales in Madrid, Spain, a country famous for using peppers in cuisine. Yet it's their roots, rather than their succulent fruits, that were the subject of new research conducted at the museum's greenhouse. Though a plant's growth above ground is highly observable, its subterranean development lacks visibility. This forces scientists to rely on piecemeal techniques to measure roots' spatial behavior or growth patterns according to distance, and limited mathematical models to predict their biomass. The recent research in Madrid sought to reconcile this dilemma. A new mathematical formula incorporated both space and biomass to build a more complete model of root growth. Researchers then tested its accuracy using a novel experiment. First, they set up soil-filled construction gutters inside a greenhouse. In some gutters, they arranged pairs of pepper plants, roughly 10 centimeters apart. In others, solitary plants were grown without neighbors. All of the plants were given equal access to light and water, as well as fertilizer rich with phosphorus, nitrogen, iron, and other key nutrients. As the plants grew, scientists injected the plant stems with red and blue dyes so that they could distinguish between the roots of competing plants. Finally, they pieced together root fragments according to their owners, measuring their density, lengths, and positions in the soil beds. Plants tend to invest resources closer to their stems, adding more roots to the soil near their source as they spread symmetrically. But the experiment showed paired plants invested even more resources closer to their stems than solitary plants. They also grew fewer roots as they neared their neighbors, where resources became scarcer amid greater competition. These patterns closely aligned with the study's model, which predicted that neighboring plant roots would segregate and change how they invest resources in order to acquire as many resources as possible. By confirming the model, the research helped resolve contradictory results from previous experiments, where root biomass sometimes increased and other times decreased in the presence of neighboring plants. Turns out, the closer the plants are to their neighbors, the more they invest in their roots overall. Their evolutionary programming causes them to add more and more roots near their stems, rather than extend across space to compete for survival. The researchers believe their findings could help genetically reprogram plants to maximize crop yields. Climate modelers could also make better projections of Earth's vegetation, a significant carbon sink, by factoring in the underground life of plants. Oh, the places they'll grow.